What's up, everyone? Tim from Toolpath here. We're going full geek mode with Steep and Shallow today in Fusion, thanks to John Bauer's request in our last Cam Geek video. Hopefully, Ben can put a link to the video somewhere up there. Last week's Geek video was supposed to cover 3D Toolpath containments, but he covered a whole bunch of stuff. Even after Ben broke it in chapters, it seemed like it was a little bit long. You tell me if it was too long or not. Keep commenting in the comments. Tell us what you like, what you don't like, what you want to see more of. I even saw some of your own pro tips in there, so keep that coming. For now, let's get to work. So, getting to work. This is what we're going to work on today. Let's start with, I'm going to look at my notes here to make sure I'm on track and not forgetting anything. We're going to start with, where do you find this? I'm going to try to do most of these. If we come down to the data panel, go to cam samples, I'm going to try to pull most of the stuff out of here. I spent a lot of years at Autodesk helping people adopt Fusion as product manager, lots of different things. There's a lot of good stuff in here. If you haven't checked it out, you should go check it out. I'm going to try to pull most of this stuff out of here so it's easy for you guys to poke at it and follow along. This one's going to be in cam samples. So if you start by going to the bottom of your data panel, there's cam samples, tutorials, and then scroll down until you see this tutorial 4 complete. Open that up and then go put it somewhere in your data panel. You just have to do a save as and save it locally. I already did that, so I'm going to close my data panel. And this is basically what you're going to start with. This is my old friend Mike Matera, I'm sure, did this. So it's a good start. A lot of the feedback that we had from the last video was how they liked the whole series, the whole kind of part overview. So I'm going to do that fairly quick here. I want to talk about this 3D adaptive. We talked about optimizing it in the last video. If you didn't see that, maybe go check it out. Mike did a 3D pocket here. I'm going to delete that. And then he just walked down some 3D toolpaths. If you're interested in a whole 3D overview, talking about different types of geometry and how different toolpaths kind of work with that different geometry, put something in the comments. I definitely have some stuff we could cover there. That's not what this video is really for. So I'm gonna go and delete a good chunk of this stuff. Yeah, maybe we want to not delete them. I want to talk about, let me come down here and turn off the in-process stock. I want to talk about how some of these toolpaths aren't great. They're actually great. This is fine. It's very easy to apply this toolpath, but it's not very efficient. It doesn't leave a great surface. So Steep and Shallow is a wonderful toolpath for blending toolpaths that are good at machining steep surfaces and good at machining shallow surfaces, and they do it in one toolpath. Previously, you'd have to use 2 different toolpaths and contain them by slope or some other way. So let me look at my notes, make sure I'm covering what I want to cover. So the first thing I'm going to do here is I'm going to come change the units to inches. Sorry for all you millimeter lovers. If anybody hasn't seen the SNL skit, go to Google and type in George Washington metric Saturday Night Live or something. It's pretty funny. Okay, so we changed that to inch. We'll regenerate this, and then this adaptive should pop up pretty quick. Yeah, so this adaptive is, because the tool's so big, it's missing the valley of that feature. And they're catching it with this pocket, which is probably fine if it's a softer material. I'm going to delete that, because what I really want to do is come in and do a 3D adaptive, but just hit that inside and talk about how to control it. I'm going to duplicate this. Let's come here and grab, I believe it's tool 13 that we want to use. Yeah, it's just a smaller bullnose. From the last video, you probably picked up a theme where I like to just grab a toolpath and use it and then go change what I don't like. So that kits that area that we were missing before, right? Just a whole bunch of other stuff that I don't really love. So there's a few ways to handle this, and let's talk about the first one first. So we'll hit edit. Part of my instinct is to come here and just, which is the stock definition, and do a selection of this. Oh, and then I'll turn off include setup stock silhouette. So that actually does a really good job of machining out that area that I wanted to machine. And if I turn on the in-process stock, you can see if I toggle between here and here, it does exactly what I was hoping. And then I realized, well, crap, I got some stuff here that I also need to rough out. So that strategy wouldn't work great, to be honest. No, I could also do some containments here. Probably what I would do is do a remaining stock from previous operation. Let's hit OK, see what we get there. It's kind of like I wanted it, right? So machine that out, and it picked away at these corners a little bit more. Now, if you want to learn how to optimize this toolpath even more, I did cover that pretty good in the last, the very first, Cam Geek video I did. So maybe go check that out. We'll save you some time here. Next thing we want to do is a 3D adaptive toolpath. So let's go do that. So 3D, steep and shallow. And how do we want to, what happens if we hit OK? Follow that theme till it teaches us otherwise, right? So let's drag this up under here. It actually looks like a really dang good toolpath, like a very good start if you ask me. Now, of course, we don't want it to go over the edges, and probably the least efficient way to machine these flats here. So what happens if we took this horizontal toolpath? So if you don't know about horizontal, there's two toolpaths that do basically, they're competing to do the same thing. So you have a horizontal toolpath. If you read that tooltip, it basically detects flat areas. And then you have a toolpath called flat. A little history there. Horizontal comes from the HSM kernel, and flat comes from the Delcam family of tools. Flat's has a little more horsepower to it. I probably use that more. They would get rid of horizontal if they both didn't have some merit. So maybe someday you'll see horizontal disappear. But I'm going to take this, I'm going to drag that up. And then when I come here, I have a couple different ways to keep it from machining that, right? We could do a rest machine, which I know a lot of people would want to do rest machine, be tempted to do that. There's a lot more calculation involved. Really what I would do is I would just grab this bottom edge here, and it actually went around the whole part pretty nicely. So let's just hit OK. Again, that looks pretty good. I was actually hoping it wouldn't look that good. Let's come here. One thing I want to do is I want to do a steep and shallow with this bigger 10 millimeter ball mill. Let's see what that gets us. So I'm going to do a semi-finish and then a finish, right? Okay, this is more what I was hoping. Reinforce some of our contact point boundary conversations we had last time. So after this rough, and finish the floor, what I really want to do is get rid of some of these steps. If you're looking for a really nice surface finish, on your last finishing toolpath of that surface, you want to be presenting the tool as consistent a cut as possible. And the way I found to do that, sometimes people feel like it's a waste of time, but the way I found to do that is to basically do a semi-finished toolpath. So we would start with this bigger tool. Edit this. Let's get this containment right. It's not quite coming all the way down. Tool center on boundary, that looks good. And we don't have contact point boundary turned on, so let's turn that on. If you're struggling to understand that, I covered it pretty good in that last video. This lets it come all the way down and machine down to there. So that's perfect. Now the step over is probably fine for a semi-finished toolpath. So let's go to passes. And let's go deep dive into the steep and shallow parameters on the next toolpath. For now, what I want to do is just have an efficient toolpath that has, let's say, 15 thou stock to leave axial and radial, and has a bigger step over. So I very commonly change my cusp height, change my step down or step over based on cusp height instead of percentage of the tool diameter or just a random number. Cusp height's translatable to me, so I'm going to do not 15 thou, I'm going to do 1.5 thou cusp height there. And honestly, I'm going to do the same here. So one tip, if you're taking notes, I like these cusp heights to usually be the same. So I'm going to come and click on these 3 dots and copy parameter name, and then I'll paste it in here. Now, if I want that to be my most common workflow, I'd come here and say save to user default. And sorry, part of this is off my screen. I'm on a MacBook Pro, so I have to do some weird stuff with my screen. But the nice thing there is if I go back and look, now these parameters tied together. So if I look at the cusp height here and I change the cusp height here to 3, it changes it down there to 3. So let's make that not 2, let's make it 2 thou. So 40 thou step over, step down. I think that'll be good for a semi-finish toolpath. Looks pretty good. Once the in-process stock over here calculates, we can see the stock. Yeah, that looks pretty good. I like that. I think our finishing tool will have a lot better chance of giving me a really consistent finish. So now it's time to do a finish toolpath. And I'm going to right click on this. I'm going to come down here and hit duplicate, however you want to say that. And there's several things I don't love about this, but let's get in and understand steep and shallow. Last week we talked about containing your toolpaths, and slope was one of the things that we talked about. And I think we need to save a deeper understanding of 3D toolpaths and how they affect different geometry types. But you basically have 2 major type of geometry types. You have steep or shallow. Steep, I consider anything 45 degrees or steeper. Shallow, 45 degrees or shallower. And there's an overlap where there's a gray area there between maybe 30 and 50 degrees, somewhere in there. So it used to be that I would take one toolpath and apply it to all the steep areas, do a slope containment from, let's say, 45 degrees to 90 degrees. And then I would do a shallow from 40 degrees to 0 degrees. With steep and shallow, it actually, in one toolpath, gives you both options. So if we come to passes, on the passes tab, you have your tolerance, you have recognize area as steep and shallow. Now, if we wanted, we could do steep only or shallow only. A little history lesson here. When steep and shallow was introduced to Fusion, it was basically a one-to-one match of very similar to how it worked in like PowerMill. And it was one of the most used and loved toolpaths in PowerMill, especially a lot of those mold makers, right? They're just dealing with all these organic surfaces, and it was really easy to break it into steep and shallow surfaces. Some of the super pro users like Rob Lockwood and I think maybe CJ, Phil Buttersworth, Devin, a lot of those guys were looking to force it to do steep only or shallow only for lots of different reasons, usually more cosmetic reasons. Or if you go to steep only, you unlock this undercut option. That was a pretty common reason why people wanted to do just steep or just shallow. In shallow, you don't have undercut options. In steep only, you have some other options that we can explore here in a little bit. I don't think this part's going to be great to explore all of those, but we'll talk about it. All right, so steep and shallow. This is going to be my go-to toolpath. The vast majority of what I machine now with 3D surfaces, I use steep and shallow for several reasons. I'll try to highlight them along the way. What is threshold angle? Threshold angle is the threshold where you cut off from steep to shallow. Now this, I will tune this. 30 is pretty much what I use majority of the time, but I'll flirt with 30 to 45 degrees on this, depending on how it lays across the geometry that I'm cutting. Overlap distance, that's how the two toolpaths overlap. If you look at the expression here, it's just the step over times 3. So you basically get 3 step overs worth of overlap. I will play with that a little bit depending on how the machine, how those toolpaths come together and how it picks up the light on the part and whatnot. Order by depth, I do like this area. I use this fairly often. And then I almost never change. Never is a long time. I don't very often change priority to top first. If you want to do the steep areas first, you can do the steep areas first. Now we get into the good stuff. Steep passes, this is your controls for that. Think about it's just a 3D contour toolpath. And if you're familiar with the 3D contour toolpath, these controls should be pretty familiar. You'll notice on steep surface toolpaths, you'll get a step down value instead of step over value. Cusp height is just a nice feature. This part probably doesn't lend itself great to spiral. And I will use spiral on a feature like that tooltip. It's great for features like that. Now we get into the shallow area. Now you have two options for shallow. You have scallop. We're going to leave it on scallop for now. Parallel. I think we're going to switch to parallel on this here in a few minutes. Optimize for open pockets. Doesn't really make any sense for this. There's no open pockets. The tooltip explains that really well, so we don't need to cover that. Spiral. We'll turn this on and off. All these other options should be pretty clear. We're going to turn off stock to leave because that's not what we're doing. And then smoothing. I think we'll talk about smoothing later. Linking, we don't need to talk about linking. Let's get into this toolpath and take a look at it. So this toolpath, we had this scallop at the top. That was fine. We have another scallop here at the top. Let me turn off the display stock, the in-process stock. So this is a great toolpath. I would run this if I was in a hurry. If I was just trying to get a quick prototype done. I'd run this and be tickled. I'd be happy. It would look great. But I like to micromanage stuff. And really, the intent of these videos is that I want to empower you guys to fine-tune your stuff. Working with Toolpath, we're really looking to increase your productivity by a ton. And part of that's going to be get you most of the way there so you can go focus on some of these little fine details and still make a profit. I'm hoping I'm not sending everybody down a path of micromanaging every toolpath you have, because hopefully you're focused on making good parts that meet the print and that you can make a profit on. There's no reason to spend your life trying to impress all your Instagram fans. Really, an old friend of mine, old mentor of mine said the only perfect part's the part that meets the print. And so what I'm just trying to do is help empower you to get better finishes when they're relevant. So I kind of love and hate. I have a love-hate relationship with the Scallop Toolpath. And that's what we have here. That's what we have over here. Let's make it a little bit better. The reason I hate it is these hard turns. I hate how it collapses on itself. And you'll also see this kind of seam over here. It looks like a little seam in the machine surface. It's great because it works at basically all the surfaces. It's what I would call a surface step over toolpath. It steps over evenly on the surface no matter the inclination of the surface or the angle of the surface. Okay, so we could make this better. My machine, and every machine made, Doesn't like to go haul butt down this direction, make a hard turn that direction, just like a race, a car on a racetrack. I wouldn't mind this nice curved corner over here, but it definitely wouldn't love to make this, U-turn here. And the smoother we can make those, the better. So let's go play with that first. Go edit, passes. And so a good example is if I wanted to use a scallop toolpath over a whole part, a good example of how I would do that, there's more toolpath control features in the shallow passes area of steep and shallow than there is under this scallop toolpath. So I would come to steep and shallow, hit shallow only. Let's just do it. Shallow only, it hides the steep area. Sometimes I'll do spiral, sometimes I wouldn't. I almost always do smooth offsets. So let's look at, remember how this toolpath looked here, and let's look at smooth offsets. Yeah, see how they're just way smoother. I don't love these. I don't love these turnarounds here. And honestly, I hate how it's going down and up this steeper surface. But there's a lot of benefits to a scallop out of steep and shallow than a scallop. And we can actually see what happens if we go to create drive, 3D scallop, hit OK. We'll just do a quick comparison. So you don't have those smooth offset options in this scallop. It's good enough toolpath to get a lot of people's jobs done, but let's get back in this. We're dancing around a bit. So let's go back here, go back to passes, do steep and shallow, hit OK. This is closer to what I would actually run. So now when we look into here, it's nice and smooth. That's a good toolpath. I'd be pretty happy with it. Gets a little weird around here. I don't love that. I would see that in the surface of the part. Yeah, anyways, let's go further, see what other options we have, further refine that toolpath. Remove cusps at junctions. This is nice. And the tooltip probably just tells you what it is. Spiral, just for the record, I love spiral when it makes sense. And this part doesn't really make sense. I'm not, if you're machining a boss like this tooltip, that's where I would use spiral. All right, so let's take a look at this center little thing here. And if this was machined as is, I would have this little cusp in the middle of that. Let's see what this does. Maybe, where else would I have it? I'd have it also right down this middle here. See this little canoe looking toolpath? When I do this and hit OK, let's see what we get. And this is more prevalent at different geometries. Like it'll be really nice. Yeah, so as I predicted, it ran a toolpath straight down the middle of that to get rid of that like little cusp. Sometimes you'll see it go out of these corners. Doesn't really make sense here with the curvature. And then it went down right down the middle here. So it got rid of those cusps. Also got rid of a little tiny baby cusp there. And it ran off there. So again, I don't like this scallop. It's not very efficient. It does some weird noisy stuff there. And this part would lend itself to a very nice parallel toolpath. Let's go back to edit. And let's just switch this. Is there any other features? No, we don't need to talk about any other features, but we'll turn this to parallel. And another nice thing about parallel in steep and shallow is you can pick a fixed direction that your parallel goes, but steep and shallow does a really good job of picking a sensible direction for it. If we wanted, we could do fixed direction and pick maybe this edge or a sketch line or something like that. There's a lot of noise in up and down moves, and I can turn those off and see if we like the toolpath, and then we can go deal with those up and down moves. But this, to me, looks like a toolpath that will complement the steep toolpath lines. I'll see some blends here. Maybe you want to play with the blends and try to get them to where they barely touch. But I think we have a pretty good start here. So let's go deal with the noise of all those relinking moves. So if we come down here, that's just a function of, we only said it could climb. So we're going to say both ways, which is common and fine and good with parallel. We'll turn on our linking moves so we can see those. And we just have a really nice toolpath here. So it's a combination of two, a steep and a shallow, a parallel and a 3D contour. Let's see what other options we have to adjust that. If we go to passes, that's pretty much what we have. How much do you want to stay away from the wall? I don't think that's relevant here, so we'll leave that alone. Fixed direction we don't need to play with, but that's where we can change the direction. So now I want to talk about the smoothing setting. If I come down here, last video you saw me turn these points on a lot. I come here and zoom. Let's see if I can find a good, yeah, if I zoom in and out a little bit, you'll see these patterns of like clusters of points. And you'll see those clusters and patterns in the light reflection of the machine surface. And your machine just moves around these kind of scattered points in a scattered way. The best surface finish I've ever seen off a Haas machine, and I'm not knocking Haas, but is on my 2008 VF2SS with a zillion miles on it, leveraging this smoothing setting and even point distribution. So a lot of people know about smoothing as arc fitting. Even point distribution is really good at giving a very even point distribution. My buddy Rob Lockwood said a long time ago in one of his videos, if you haven't watched them, they're all pretty old, but there's so much good stuff in there. What did he say? Good toolpaths make good parts. It's something that simple. Usually the most profound statements are that simple. And this is a good example of just a good toolpath makes a good part. So all these points are very evenly distributed across the surface, and that will make a lovely surface finish. Now you want to play with those point distribution. On my VF2SS with high-speed machining turned on, 20 thou point distribution seems pretty good. Some old Mazaks I ran, the more points the better. They have some good smoothing stuff in there. Datrons have really good smoothing algorithms. So maybe play with even a finer even point distribution at a smaller points over there. I think that's pretty good. So there's magic there. Let me just share that. Don't undervalue that. For anybody that has just your control can't process code very well, like a lot of code, you might need to go to arc fitting. And if we look at this real quick, so I hit cancel. And so we have 2.2 megabytes is the toolpath size for that. That's not small. Some people might say it's huge. If I go to arc fitting, let's see what that gets. The point distribution on this should be a lot less. Yeah, so we're 242 kilobytes instead of 2.2 megabytes. And when I turn on the point distribution, you see way fewer points. So this might make a machine that struggles with processing code, this will make a machine that struggles to process code, either a cheaper machine or a machine that doesn't have high-speed machining or just something that has a bad memory without a drip feed. Not bad, but low memory. This will just be much better. What it does is it translates things as much as possible into straight lines and arcs, like G2, G3 arcs. That's pretty good. So what else do I want to change on this toolpath? I don't love these. I'm getting about as long as I want to be, so I'll try to wrap it up. I don't love how it's handling this fillet here. I'm guessing it's because this is 8. My tool is, no, I'm still on tool. I need to change that to a smaller tool. Yeah, I have a 6mm tool. So let's see how it handles that fillet at the bottom. I suspect it'll still do some stuff in here. Yeah, so on the steep areas, it handled it fine. I just don't love it. It's not great. There's a few options we can do to try to get it off the bottom. And the one I'm going to use is, I'm going to go to geometry. I try not to do surface selections as whenever possible, but this is a really good example of fairly new functionality that we're going to add, and we'll just pick all of these surfaces here. Anybody asking? I know in the last video some people are asking about how I move the model around. I do use a space mouse. John Saunders, I think, specifically loves them. That's a joke. If you don't watch any of his videos, you should. He doesn't love them. It is an acquired kind of skill. I think anybody doing this full time every day should consider one. So I picked those instead of, that just saves a lot of kind of mouse move. So I picked all those surfaces. I'm going to say avoid surfaces. I actually don't care if it touches it, so I don't need to give it a clearance. I'm just going to say avoid them. Let's see what that gets us. That's fairly new functionality. That's really powerful. It's super powerful. And it's probably makes things a lot more intuitive for some other people coming from Mastercam and some other more surface selection type tools. Yeah, so that just kept it off the very bottom. Let's hit simulate, see how far it down actually goes, and then I'll talk to you about pencil or the corner finishing tool, which is what I would really use. Not toolpath. I want to turn off stock, and I just want to click on one of these intersection points here and just walk it back and forth. I talked about this kind of being able to scrub, left mouse click, hold, and scrub back and forth to see. It's really good to see how it interacts with your geometry. Yeah, this looks great. And it's a bit off the bottom, which is what I wanted. I want to have it's already done, so I want to have a toolpath like that. I like that a lot. Let's get rid of this. I don't like how noisy it is. It's ugly. Get rid of that. Collapse that. Get rid of this and this, and then we'll talk about pencil, maybe corner, and then we'll wrap it up. Maybe we'll do one like segment geometry with steep and shallow. Yeah, I'll do that before we're done. I'm not going to talk about this one. I would never do that. Pencil, I very often say this is like dipping your part in chrome at the end. If you have fillets, these internal fillets like that, a really good pencil is just adds a little chrome, a little nice finishing touch at the end. Should also explore corner. Let's see what happens if we come here, go to derive, 3D milling, and corner, and see how good of a result we get. It has to do a reference tool. So we're going to come here, we're going to pick this tool. It's basically saying what was the tool you used before this, so it knows how much to cut. This is a great tool for molds. And not always great with what I call cosmetic parts, where we like care more about the cosmetics of this. What's awesome about it is that it picks out the corners, the steeper corners. It does in a smarter toolpath. If we compare it to this, will show more flow and just aesthetically look better. And this by nature treats it like a pencil, a steep and shallow pencil, basically. So this is a beautiful toolpath, especially when you consider it has smoothing and it has even points distribution, right? And then you also have, for the steep areas, you can force it to do along with maximum step over. So we should get something very close to this toolpath, probably with better point distribution. The problem is I would anticipate some kind of linking moves that I might not love. Let's see what we get. Yeah, so this is great. It's actually really good, but I don't love it how it broke it up here. I'd probably stick with this. And learning the pencil toolpath is a whole video by itself. But essentially, you pick a tool, and then I'm sure there's some over thickness. Yeah, this over thickness is worth reading this tooltip, but it basically says this fillet is 8 millimeters. This tool is 6. So in the over thickness, you would want to say I have at least two millimeters of over thickness, and it'll go find that fillet. So just a quick little tip. I'm running along again. I could talk cam all day. If we went to, yeah, I'm going to turn that off. Let's make sure we get the right result that we expected. I don't know why stock to leave was turned on. Yeah, so we get a good result. And if we came here and made, I'm just going to, yeah, we'll zero that out. We basically don't get any result because there's no fillet that matches 1-to-1 with a 6 millimeter ball mill. If I came here and typed 50 thou, I think it was 47 before. Yeah. So you're basically saying, go find any fillets that are that much bigger than my tool. And then the last thing I'll say on this, that's going to make the part look really good. Last thing I'll say on that is that this number of step overs is not the total number of step overs. It is the number on each side of center. So if that's 5, let's go count our toolpaths or toolpath lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 5 on each side of center. So if we wanted that to be 4 total, no, we won't get 4 total, right? We would want to do, if we want 5, we would do 2. Yeah, 2. So it'd be 2 on each side and the 1 down the middle. With that, I appreciate everybody's feedback on our last video. We can keep this going if we keep getting views and we keep getting feedback and interactions. I'm happy to keep sharing everything I know. I held off for a long time doing these because they're not super relevant to Toolpath. Until I realized our goal right now with Toolpath is to get you to 80% of the way and then give you the time to put the little nice finishing touches on the end. And I think we're heading in the right direction for that. I think I'm seeing some really good stuff out of development. So go try Toolpath. I understand that the cam side of it's still in beta, but I think it's really interesting. I think the estimator is really valuable right now for people that are quoting parts. And then our job is to make you more productive and give you more time back in your day to do things like catch the finishing details, design better fixtures, maybe go play golf every once in a while. Let me know what you want to see more of, what you want to see less of. Look forward to talking to you guys more. Cheers.